All right, guys, I'm going to go through and solve this next grouping. I'm going to go a little bit quicker. If you have any questions, if any of this, you're like, I don't know what she's doing, please stop me and ask me, but I'm going to go through this a little bit more quickly on this one. So we have tin 4 sulfide. We want to know what the chemical formula is for that. So when you go from the name to the formula, you always go back to the ions. So tin 4 means that we have tin, which is element Sn, that has a +4 charge. Sulfide is based on sulfur, and it's S that has a 2- charge. When we bring those together in the ratio that balances them or has them neutralized to 0, the chemical formula is SnS2. We need 2 sulfides for every 1 tin in order that that goes to 0. Sodium phosphate. Sodium is a group 1 metal. It's a main group metal. So sodium will have a +1 charge always. That's why there's no Roman numerals after it. It's a main group metal. Phosphate is one of the polyatomic ions that you just have to memorize. Again, it has that 8 ending, ATE, that usually indicates that it is a polyatomic ion. Not always, but a lot of them have that ATE ending. So sodium has a +1, phosphate has a -3. When we bring them together, we need 3 sodiums for every 1 phosphate. So Na3PO4. One thing that sometimes students do is they'll put parentheses around it, even if you only have 1 of them. I don't care. It really is not technically correct. And so you'll see me like cross it out all the time on your exams. If you only have 1 polyatomic ion, you don't need the parentheses. If you put them in, I'll just cross them out. It's not wrong. It's just not 100% correct. Lead-2 oxide. Lead is one of the transition metals. Lead-2 means that we have lead with a 2+ charge. Oxide is based on oxygen. Oxygen is in group 6. It gains 2 electrons to look like a noble gas. So that means that the oxide ion has a 2- charge. So PbO is the chemical formula for lead-2 oxide. Going from formula to name, first thing you got to figure out is it's a transition, and nickel absolutely is a transition metal. So since nickel is a transition metal, you have to give its charge in Roman numerals. So this is going to be nickel something bromide. Break it down into its ions. We have 1 nickel. It's going to have some kind of positive charge because metals make cations. We have 2 bromides. Each one of the bromides has a -1 charge. So that means overall we have a -2 portion of the compound. So we have to have a +2 portion of the compound. So the name for this guy is nickel 2 bromide. Na2S, sodium is a main group metal. Sodium is an alkali metal, so it does not need Roman numerals. The only ones that need Roman numerals are the transitions. Group 1 and group 2, they do not need Roman numerals. This is the most straightforward. This guy is just sodium sulfide. Strontium bromide, go back to the ions. Strontium is in group 2. It's an alkaline earth metal. So strontium will have a +2 charge. Bromide has a -1 charge. So when we bring them together, this compound is SrBr2. We need 2 bromides for every 1 strontium. Magnesium nitrate, nitride, not nitrate, that's different, nitride. Magnesium nitride is Mg that has a 2+ charge, that's the magnesium ion. Nitride is N that has a 3- charge. Nitrogen is in group 5. So it gains 3 electrons to look like a noble gas. Again, this is the hardest I can get. We're going to have to find the least common multiple of 6. That means that we need 3 magnesium ions and 2 nitride ions. So Mg3N2 is the chemical formula for magnesium nitride. Then we have Li2SO4. We're giving it its name. Lithium is not a transition, so we don't have to worry about Roman numerals. So then you just have to memorize. SO4 is the polyatomic ion of sulfate. So lithium sulfate is the name for that guy. Good? I know you guys are like, I don't want to do this anymore. Moving right along. We have Cu, CH3CO2, 2. Copper is one of the transitions. So that means that this is going to be copper something. So we're going to have to figure out its charge. And then you have to have memorized that CH3CO2 is the acetate ion. So this is copper something acetate. Copper is going to have a positive charge because metals make cations. We have 2 of the acetate ions. Each one of the acetate ions has a -1 charge. So that means that overall, it has a -2 charge. Overall, this has -2, so that portion of the compound is -2. So the positive portion has to be +2 in order to balance it out, have it come to 0. So this guy is copper 2 acetates. Silver 1 chloride is Ag, that has a +1 charge. Chloride has a -1 charge. It is a match made in heaven. So this is AgCl. Silver 1 chloride is used in the development of Polaroid film. I think it's very, very interesting how Polaroid film works. It's a chemical reaction that involves silver, and I think it's really cool. But that's why digital is cheaper than like photographs and Polaroids. Why Polaroids are so expensive is because it has silver in it. I was in grad school, and platinum is really expensive, right? Like if you're buying like wedding rings and stuff like that, like the most expensive metal you can get for a wedding ring is platinum. And there was a professor who did research on platinum, and he had to like lock up his platinum because it was so expensive to buy. So that kind of translates down just from like wedding rings and stuff like that to the actual metal used in catalysis. I think it's really interesting. I never use anything expensive. I used some platinum, but I use like milligrams. I used a lot of nickel, but the platinum in the locker, the locked box, I thought was interesting. Anyways, moving on. Calcium hydroxide. Calcium is one of the main group metals. It's an alkaline earth metal. So calcium will always have a +2 charge. That's why there's no Roman numerals. Hydroxide is one of the polyatomic ions that you just have to memorize. It's like our friend school, Ohio State. So we have OH that has a -1 charge is hydroxide. So when we bring them together, we're going to have 1 calcium for 2 hydroxides. Since we have more than 1 polyatomic ion, we put it in parentheses. So CaOH2 is the chemical formula for calcium hydroxide. One of my least favorite chemicals. The reason, and again, this doesn't matter at all, but I have to entertain myself. Calcium hydroxide is this white powder, and it's like really, really puffy. So every time you go to like weigh it out, and I do this whole lab for second semester 1520, where we have to weigh out massive quantities of this calcium hydroxide. Every time you like scoop it out to like put it on the balance, it like poofs up, and you just get calcium hydroxide everywhere. My least favorite chemical. NaHCO3. Sodium. This is sodium is a main group metal, so we don't have to worry about the parentheses with the Roman numerals. So this is sodium. And then HCO3 is one of the polyatomic ions that you just have to memorize. This guy is sodium bicarbonate, also known as baking soda. And last, we have nickel. Nickel is one of the transitions. So you got to give me its charge in Roman numerals. So it's nickel something sulfide. Breaking it into its pieces, nickel is going to have some kind of positive charge. Sulfide has a 2- charge because it's in group 6, and it gains 2 electrons to look like a noble gas. So nickel has to be +2. So this is nickel 2 sulfide. Good? Making sense? Beautiful. Now, here's where it really matters. We are going to take chemical equations from words and translate them into symbols, and then we're going to balance it. So we're going to take the chemical equation from words to symbols and then balance. Let me try to get rid of my bar over here. I want it to go away. Oh, it's not going to. No, it's not. Oh, that's a giant pain. That's okay. Oh, that's good enough. I'll go over. Oh my goodness gracious. Whatever. Okay, so the first thing that I want to tell you about is phases. Okay, so there are 4 different phases that are denoted in the chemical equation in words that need to come down into the chemical equation in symbols. So there are 4 different phases. So one of the phases is that it can be a solid. What abbreviation do you think we can have for solid to denote that it's a solid? An S! Oh, for the win. So solids get denoted with an S. Another phase that we can have is that it is a liquid. What do you think we're going to abbreviate liquid with? NL. Oh my gosh, you're right. Another possible phase that we can have is a gas, which gets abbreviated with a G for the win. Now, here's actually the hardest one. This one is actually used the most, absolutely the most used, but it's a little bit trickier. The name for this guy is it is in the aqueous phase. Aqueous phase means dissolved in water. Water isn't part of the chemical reaction. Water is just the solvent. It's just the thing they're doing, the dissolving, getting all of the chemicals to actually mix. So aqueous means dissolved in water. And the abbreviation for that one is AQ. So if it's in an aqueous phase, that means dissolved in water, and it is AQ. So here we go. This is what I recommend. And again, I don't think that these are hard. I think that students sometimes rush. So the best thing I can tell you guys is don't rush, just take your time. So we have solid copper. That's going to be our first reactant. So what is the chemical formula for solid copper? Cu. And I'm going to denote in parentheses afterwards that it's in the solid phase. So Cu with an S in parentheses afterwards means solid copper. Reacts with tells me that I'm going to be adding in another kind of compound. So solid copper is Cu with an S. Reacts with is our plus sign. And then our next reactant is an aqueous solution of magnesium chloride. This is where you have to be careful. And again, this is where I'm telling you have to slow down. So you have to go back and think to yourself, okay, magnesium chloride, it's an ionic compound. We already know it's ionic because I haven't taught you about the other ones. So magnesium chloride is ionic. Go back to the ions. Magnesium has a 2+ charge. Chloride has a -1 charge. So what's the chemical formula for magnesium chloride? MgCl2. So you guys have to be careful when you write the chemical formulas or the chemical equation from words into symbols. You have to make sure you have the right formulas. If you go through and try to balance something and you don't have the right formulas, it will never balance. So you have to make sure that you have the right formulas. So this is aqueous magnesium chloride. So it's MgCl2, and it has that AQ next to it. So that's our reactants. Then we have to yield. That's telling us that we mix those things together and out come our products. So solid copper reacts with magnesium chloride, an aqueous solution, to yield. Now we're going into our products. Copper 1 chloride and solid magnesium metal. So again, take your time, slow down, don't try to rush it. What is the chemical formula for copper 1 chloride? CuCl. Copper 1 means that we have copper with a +1 charge. Chloride is from the halogens, which are in group 7. Gains 1 electron to look like a noble gas. So this is a match made in heaven. They come together 1 to 1. The fact that it's in a solution is telling me that it's aqueous. So in a solution, dissolved in water, an aqueous solution. Those are all the same kind of ways to say that it is aqueous. And our next product is solid metal. Solid magnesium metal, I'm sorry. What is the chemical formula for solid magnesium? Just Mg. No charge. I'm not talking about ionic magnesium. I'm just talking about solid magnesium. So this is the skeletal equation. Cu as a solid reacts with MgCl2 is an aqueous solution to yield aqueous CuCl and solid Mg. Now that we have it as its skeletal equation, we're going to change the coefficients. Change the coefficients in fronts to balance the chemical equation. Oh, it's trying. I know you want. Yes! Oh, that just made my whole day. So we're going to change the coefficients in fronts such that we can get this chemical equation to balance. You can't change the subscripts. Changing the subscripts changes the formula, changes the compound. We're just going to change any of the coefficients out in front. So I'm going to do this just by inspection. You can go through and do the atom inventory. We talked about atom inventory. We haven't talked about atom inventory. We haven't talked about, fair enough. Let me show you what I mean then. So what we're going to do in order to balance this chemical equation is we have to make sure that the number of atoms in have to equal the number of atoms out. You can't change anything. What goes in has to be what comes out. So let's do the atom inventory for this. I'm just going to go through and tally up how many atoms of each type I have in the reactants, how many of each type I have in the products. So how many coppers do I have in my reactants? Just 1. How many magnesiums do I have in my reactants? Just the 1. And how many chlorines do I have? 2. That's what I mean by doing an atom inventory. We're just taking into account all of the atoms that we have in our reactants. Now I'm going to go over to the products, and I'm going to do the exact same thing to see if we need to balance or not. I like to just keep it in the same order, so I went copper, magnesium, chlorine. So I'm going to go copper, magnesium, chlorine in the products. So how many coppers do I have across both of my products? Just the 1. I'm going to go to magnesium next again just to keep my columns like organized. How many magnesiums do I have? And how many chlorines do I have? It's not balanced. Wah, wah. 1 copper in, 1 copper in, we're good. 1 magnesium in, 1 magnesium out, we're good. 2 chlorines in, 1 chlorine out, that is bad. So we have to change the coefficients in front of the compounds. You can't change the subscripts. Changing the subscripts changes the molecule, right? Like we could go from H2O, that's nice, happy water, we all drink it, it makes us happy. If we change the subscript, we change it into H2O2. Does anyone know what H2O2 is? Hydrogen peroxide. You don't want to drink hydrogen peroxide. So changing the subscripts is not allowed. You can only change the coefficients that come in front. So we need to change the coefficients in front of this copper 1 chloride so that we can get 2 chlorine. So what coefficient can I put out in front to get me up to 2 chlorines? A coefficient of 2. This coefficient of 2 gets distributed to everything that comes after it. So that is now going to change my atom inventory of copper And that's going to change my atom inventory of chlorine. Both of it. It changes everything that comes after it. So, how many coppers do I have now? 2. And how many chlorines do I have now? 2. Check, check. That's what we were trying to do. Good. But, unfortunately, we messed up our coppers. So now we have to add a coefficient to our reactants to balance out the number of coppers. So what coefficient am I going to add in front of my copper so that my coppers are balanced? 2. That changes the atom inventory of copper, and thank goodness we were trying to get to 2, and we did. So now check, check. This is balanced. 2 coppers react with 1 magnesium chloride to yield 2 copper 1 chloride and solid magnesium. Good? Good. All right. We're getting there. Almost done. Let's take a look and translate this from chemical equation from words into symbols again. We have solid sodium bicarb reacts with calcium phosphates that has been dissolved in water. That's just telling us the phase. That's not telling us anything about water being in the chemical reaction. That's just trying to tell us that it's an aqueous phase. It does not appear in the chemical reaction. To give, that's telling us now that we're switching to our products. And our products are calcium bicarb and sodium phosphate. And then that stays dissolved in water. Again, that's just telling us the phase. Water is not participating in the reaction. It's just telling us water is there as a solvent, and it is telling us it's in the aqueous phase. So, solid sodium bicarbonate. What is the chemical formula for sodium bicarbonate? NaHCO3. Bicarbonate is one of the polyatomic ions that you just have to memorize. Sodium is NH+. Bicarbonate is HCO3 that has a minus. So that's a match made in heaven. That's going to react with calcium phosphates. What is the chemical formula for calcium phosphates? That is calcium phosphide. Phosphate is one of the polyatomic ions that you have to memorize. So you're very close. That is absolutely the right chemical formula for calcium phosphide. So just so you guys are aware, he said Ca3P2. That is calcium phosphide. The IDE ending tells you that it's coming from phosphorus, but this one is phosphate. Phosphate is one of the polyatomic ions that you just have to memorize. So, chemical formula for calcium phosphate. Ca, how many of them? Well, we do, but they don't come together in a 1-to-1 ratio. Calcium has a +2. Phosphate has a -3. PO42. Yep. That is calcium phosphates. The phase on that is aqueous. To yield. Calcium bicarbonate. What is the chemical formula for calcium bicarbonate? Calcium has a +2. Bicarbonate has a -1. CaHCO3 2. We need 2 bicarbonates for every 1 calcium to balance that out. That's aqueous. And sodium phosphate. What is the chemical formula for sodium phosphate? Sodium has a +1. Phosphate has a isn't what solid? Oh, you're right. You're totally right. No, you're golden. Okay, sodium phosphate, you were totally saying it right. Na3PO4. We need 3 potassiums for every 1 phosphate. Nope. Nope. Just running out of room. Good enough. Na3PO4, and that one is aqueous. All right, this one is going to be tricky because we have lots and lots of compounds. And another reason that I say that this one's going to be tricky is that if you look and see oxygen, we have oxygen in all 4 of our compounds. So we have to really be careful about the best way to approach this. So let's go ahead and do the atom inventory. So I'm just going to go left to right across my reactants. So how many sodiums do I have? 1. How many hydrogens do I have? How many carbons? I agree. Now be careful. How many oxygens do I have? Nope. How many oxygens? 11 oxygens. We have 3 oxygens in the NaHCO3. And then we have 2 times 4 is 8 oxygens in our calcium phosphate. So 3 plus 8 gives us 11 oxygens. Next up we have calciums. How many calciums do we have? And last, certainly not least, how many phosphoruses? 2 phosphoruses. So this subscript on the outside of the parentheses gets distributed to everything that comes inside. So 2 phosphoruses, 8 oxygens. I'm going to, again, keep it in line just so I can see what I have to balance and what I don't have to balance. So we'll start with sodiums. So how many sodiums do I have in my products? 3 sodiums. Next up is hydrogens. 2 hydrogens. Carbons. 2 carbons. Oxygens. 10 oxygens. 2 times 3 is 6. Plus 4 gives you 10. How many calciums? Just the 1. And last but certainly not least, how many phosphoruses? 1. Okay, so this is a lot, right? Okay, like nothing is balanced. And some of them are even looking like, what the heck? How am I supposed to balance this out? So I'm going to give you like a rule of thumb. Leave hydrogen and oxygen to the end. Okay, hydrogen and oxygen have a tendency of taking care of themselves. So leave hydrogen and oxygen until the end. And the other tip is start with nonmetals. So that means we're going to leave phosphorus to the end as well. Because I'm getting tired and I want to be done, I am actually going to start balancing you out with calciums. All right, so the sodiums are not balanced, I agree. But let's actually start with the calciums first. So we have 3 calciums in. We want to get 3 calciums out. So what coefficient am I going to put in front of the calcium bicarbonates? Coefficient of 3. Remember, that's going to change the atom inventory of calcium, hydrogen, carbon, and oxygen. Everything that comes after that coefficient now has to have a new atom inventory taken. So we wanted there to be 3 calcium. So check, check, we got that. How many hydrogens do we now have? 6 hydrogens. There's 2 from the subscript times 3 from the coefficient. That gives you 6. How many carbons? 6. Be careful. I have to do the math in my own head. Yep. How many total oxygens do we have? I didn't get 16, but that might be because no, I think I'm right. I don't think it's 16. to take another guess? How many oxygens do we have? I got 22. So we have 2 times 3 gives you 6. 6 times 3 gives you 18. And then 18 plus 4 gives you 22. Did you get 22 after looking at it again? Beautiful. Okay, so really that didn't help us like that much. I mean, if you look at this, this is still a hot mess of a disaster. The only thing that we have balanced right now is calciums. So that's nice, but let's keep going. Let's actually go ahead and balance out the phosphoruses. That one's like a straightforward looking one that we have to balance. It's not going to change my atom inventory of too much stuff. So let's go ahead and balance out my phosphoruses. So I have 2 phosphoruses in. I have 1 phosphorus out. So I'm going to put a coefficient in front of the sodium phosphates. What coefficient do I put in front of the sodium phosphates? 2. That's going to change the atom inventory of sodium, phosphorus, and oxygen. So how many sodiums do I have now? 6 sodiums. How many phosphoruses do I have? 2, thank God, that's what I was shooting for. And again, the hard one. Be careful. How many oxygens do we have? 18 plus 8. We added, 20. What did you guys say? Oh my God. 3 times 2 times 3. I feel like that scene in Clue. Is Clue like not popular anymore? You guys should all watch that movie. It's amazing. 2 times 3 times 3 plus 8. It's 26. Oh, and that's oxygen, not calcium. I'm going to watch Clue tonight just to mess with you all. Okay, so now, good, we've got calciums balanced, we've got phosphorus is balanced, nothing else is balanced. Let's go ahead and balance the sodiums now. So we have sodiums, 6 sodiums in the products, so we need 6 sodiums in the reactants. So I'm going to add a coefficient of 6 in front of the sodium bicarbonate. That unbalances sodium, hydrogen, carbon, and oxygen. Now I have 6 sodiums, thankfully. That's what I was shooting for. I've got 6 hydrogens. Check it out. Hydrogens are balanced. Carbons, I also have 6. Well, life is good. Carbons are balanced. And now our favorite atom ever is oxygen. How many oxygens do we have? 6. I swear to God. 6 times 3 plus 8. 26 for the win. And now this chemical formula is balanced, chemical equation. 6 sodium bicarbs react with calcium phosphate. 2 yield 3 calcium bicarbonates and 2 sodium phosphates. This is one of the harder ones. Again, like, you know, talking about like balancing chemical equations, this is definitely one of the harder ones. All right, last but certainly not least. And I'm just going to kind of fly through this one. Mostly because I need to go to bed. I'm really tired. A solution of hydrochloric acid. Eventually, you guys will have to memorize what hydrochloric acid is. Not yet. But hydrochloric acid is HCl. And it's in water, so that means that it is aqueous. That will react with calcium carbonate, which has the chemical formula of CaCO3. And that is a solid. So hydrochloric acid reacts with calcium carbonate to give liquid water. This is, for me, how I try to tell you that water is in the reaction. If I say liquid water reacts or liquid water is formed, that's your sign that it's part of the chemical reaction. Carbon dioxide that bubbles out of the solution, that means that it's carbon dioxide as a gas. And calcium chloride that stays dissolved, that's CaCl2, and that means that it is aqueous. So that is our skeletal equation. I'm going to go ahead and balance this by what's called inspection. Rather than writing out the whole chemical inventory, I'm just going to go back and forth and see how to balance this guy. The first thing I'm going to look to balance is calcium because it's my nonmetal. I've got 1 calcium in, I've got 1 calcium out, so calciums are balanced. The next thing I'm going to look to balance is actually my chlorine. Leave hydrogen and oxygen to the end. So we're going to balance out the chlorines. We have 1 chlorine in, we have 2 chlorines out, so I need a coefficient of 2 in front of the HCl. And honestly, it's now balanced. So that 2 chlorine matches with that 2 chlorines. We need 2 hydrogens. So, because, oh, great. 2 hydrogens, because we have 2 HCl, so we have 2 hydrogens there. We have 2 hydrogens in the water. Balanced. Chlorines are balanced. 1 calcium to 1 calcium. 1 carbon to 1 carbon. 3 total oxygens. 1 plus 2 gives me 3 total oxygens. So that is the balanced chemical equation. All right, so that is the end of the material for exam 1. So your exam is next week, Friday. I always end the material the Wednesday beforehand. I hated it when I was a student and my professor would be teaching and then they'd be like, oh yeah, by the way, there's a test on it tomorrow. I hated that. So because of that, this is the end of the material that's on exam 1. So from everything up until now is on exam 1. The stuff you have to memorize, please, 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 the metric system and those polyatomic ions. There are 10 of them. Get your flashcards, get those polyatomic ions memorized. The other stuff that'll be on there is density, atomic theory. That means like protons, neutrons, electrons. Lethal dose questions that have to do with dimensional analysis. Mixtures, pure elements, compounds, the electronic configuration. I didn't do orbital filling diagrams with you guys, so we're not doing orbital filling diagrams. Ion formation, ionic nomenclature, balancing chemical equations. So that is the end of the material for exam 1. All right. Are there any